or this as rho. I think engineer Liu likes using this one. And this one uses. So each of them, the same thing. This is rho, the same thing. Alright, next up is relationship between, please if you have a question, ask who. Relationship between mass density and weight density. Relationship between, let's look at relationship between mass and weight. Density. So here's your note, please. Here's your note. Note that number one, we said mass density, which is rho, is equal to mass over volume. Number two, we said weight density, also called specific weight, W, is equal to weight over volume. Now, here's what we know. Recall that weight is equal to what there? Mass times what? Gravity. True? Right. Weight is mass times gravity. So here's what. Replace this one here into 2. Put this one here into 2. You have that specific weight is equal to weight all over volume. But weight here is equal to mass times gravity. So replace weight here by mass and gravity. It gives you mass times gravity, which is weight, all over volume. Segment this one out of it. This is now equal to, remove these two from here. I have mass over volume times gravity, of course. So mass over volume times gravity will give you this. But this one here, we said is rho. So hence, weight, specific weight W is equal to this one here, we said is rho, becomes rho times G. This is the relationship between specific weight and specific mass, rho times G. So what you have noticed this, specific weight depending on your author, alright? Specific weight is either abbreviated by a small w or sometimes we use gamma. Right. So I'm saying specific weight is also abbreviated by gamma. So note it please. So for specific weight, either use a small w or use gamma. So we're saying that w, specific weight, which is equal to gamma, is equal to rho g. They are the same thing, depending on your author. Alright, so I have this. The last type of density specific volume. Last type of density, specific volume. This is the ratio, specific volume. This is the ratio of volume to mass of a fluid. This is the ratio of the volume to the mass of a fluid. Ratio of the volume to the mass of a fluid. It is the inverse of mass density. Ratio of the volume to the mass of a fluid. It is the inverse of mass density. And is abbreviated by small v. So small v is for specific volume. So Z is the ratio of volume to mass. Volume all over mass. Get units. Volume, of course, is a meter cube. Mass is a kilogram. So the SI unit is meter cube per kilogram. So you have the space. Meter cube per kilogram. Of course, we are saying that V is equal to the inverse of mass density. Please take this seriously. Alright. So V is the inverse of mass density. So instead of mass over volume, becomes volume over mass. We'll have this. Alright. What do you have note? What do you have note? Note that the density of any, take down this. Note that the mass density of any fluid is a constant. Note that the mass density of any fluid is a constant. For water, the density or the mass density, of course, becomes 1000 kilogram per meter cube or 1 gram per cm cube. Please, I cannot stress this enough. The mass density of water is 1000 when you're talking about kilogram and meter cube. When you're talking about gram and cm cube, becomes 1. Very important. Very important. So let's call this raw water. Let me call this raw water. Next up, for mercury, density of mercury is equal to 13,600 kilogram per meter cube or 13.6 grams per cm cube. Please note this too. Now, once I'm solving complex problems on fluid, they'll just tell you water, they say mercury, and they'll not give you this one here. They expect that you should know it. You should know it. So know this please. Alright, example 1. Number 6, specific gravity. Take that please. Specific gravity is the ratio of the specific weight. Specific gravity is the ratio of the specific weight of a fluid to the specific weight of water. Specific gravity is the ratio of the specific weight of a fluid to the specific weight of water. We're saying specific gravity is equal to use the word liquid. Use the word liquid. This is how they will most likely define this for you, but this definition is not correct. Alright, of course, as you go higher in science, they advance it. Now listen, when we say specific gravity, let's write this here. Specific gravity. So we said ratio of specific weight of a fluid. This stuff is not correct, totally. Because when we say fluid, of course, fluid is a complex term for two states of matter, which are liquids and gases. Now when you say ratio of specific weight of a fluid to water, we are using water here when the fluid considered is a liquid. Let's say I'm taking, let's say I want to take the specific gravity of, let's say any liquid, let's say kerosene, right? The specific gravity of kerosene will now be specific weight of kerosene all over specific weight of water. Why? They are both liquid. What if we're considering a gas, let's say chlorine gas or methane gas? For methane gas now, it will not be specific weight of methane gas to water. You don't compare gas to water. So for air or for gases, what should it be? It's air. Please. So why do we use water and air? Why do we water and air? We look at that word under compressibility and perfect gas. But this one is not okay. Don't worry. let me change this to liquid, please. Let's use liquid here. Liquid. Worthy of note here is the fact that this is a dimensionless quantity. It has no SI in it. Very important, because I'm comparing specific weight to specific weight. Specific weight, check, we said is measured in Newton per meter cube. That's weight over volume. To become Newton per meter cube, dividing Newton per meter cube, they both cancel out. So it has no SI in place. Number 7, relative density. Relative density, of course, the ratio of the density of a liquid to the density of water. So relative density, RD is equal to, so is a ratio of density of a liquid, density of liquid all over density of water. Why water? Water is called a standard fluid. It's a standard fluid. For liquid, the standard fluid is water. For gases, the standard fluid is air. Note that relative density is a constant. It's very important. So this note that the relative density of any fluid is a constant and hence has no SI unit. It's very important. Relative density has no SI unit. Why? For this is kilogram per meter cube all over. This also kilogram per meter cube. They both cancel out. So these two do not have SI units. Also note that, very important, that specific gravity is equal to, what you were saying, is equal to relative density. This is not totally true. When I did my own calculation, it's not totally true. They are approximately the same thing, not totally the same thing. So note that in fluid mechanics, we exchange specific gravity and relative density as the same thing, but they are not the same thing. But they have approximately the same value. So when I did my calculation, I think what I got for this man was about 14.88. This man was about 15.02. So look at it, they are not the same, but they are very close. Right, so but for now, we assume that specific gravity and relative density are the same thing, please. That's this. Now, if this is true, look at it. If this is true, here's your inference. You can infer that specific gravity, we said, is equal to this man here. Relative density is equal to what I have here. Density of liquid all over, we said density of water. We said this man is a constant. Whose value is what there? 1,000 kilogram per meter cube. So check this out, please. If I do my cross multiplication, it means that the density of a liquid, of course, not just density, but what there? Mass density. So the mass density of a liquid is equal to 1,000 times either its relative density or 1,000 times its specific gravity. Please note down. 1,000 times either relative density or specific gravity. So if I'm given the relative density of a fluid, I'm asked to find its mass density. Simply multiply that value by 1,000. And that's it. Alright, so let's take some questions. Example 1. Calculate the specific weight, specific mass, and specific volume of a hydraulic fluid whose specific gravity is 0.85. Right, let's get this man done, please. Solution. The only thing we are given there is specific gravity. So given I'm given specific gravity SG as 0.85. We have to find what that? Specific weight, specific mass, specific volume. Let me clear up something. At this stage in science, you don't answer a question in the order it was given. At this stage in science, you answer a question in the order as convenient by you. If I look at what I have there, it's easier to find specific mass first. True? Yes. But if I look at the question there, which one comes first there? Specific weight comes first. But it's easier to find specific mass first. So start with mass and leave weight. You can answer any one, anytime, still correct. Of course, recall something. Recall that we said specific gravity is equal to relative density, which becomes mass density of the said hydraulic fluid. So I'm using HF as hydraulic fluid all over mass density of water, H2O. So we have this, all right? Specific gravity or relative density. This man here is a constant. So it means that specific gravity is equal to mass density of hydraulic fluid all over. This man is 1000. So I'm having this. Of course, this one comes here. So it becomes, this value is 0.85. So I'm having this times this. Mass density of the hydraulic fluid is equal to 1000 times specific gravity. Input values, this becomes 1000 times, this value is 0.85. If I multiply them, this gives you 850. At this point now, input units. We said this is measured in kilogram per meter cube. So the mass, the specific mass is 850 kilogram per meter cube. At this point here, whichever one suits you better, use it. How do I mean? The next one there says specific volume. Specific volume. We said specific volume V is equal to what there? The inverse of mass density. Of course, for hydraulic fluid, this is now equal to the inverse of this man is 850. Please give me value. What do you have? 0.00118 units. Meter cube per kilogram. So I have this one. Finally, number 3. Number 3. Specific weight. Specific weight. What's the relationship there? We said specific weight gamma is equal to what there? Specific mass rho times what there? Gravity. So let's check. Alright, input value. This is now equal to this value here is 850. That becomes 850. Gravity is a constant 9.81. Multiply this with what do you have? 8338.5 units. Newton per meter cube. Alright, so I have it. So this is how you play with this, guys. For a start, this is how you play with this. Any questions, please? Any questions, please?